Hello, my dear thinkers. Now it is time for us on this 11th May 2026 to fabricate our water level indicator on a breadboard. So we have shown you the circuit schematic drawing here. According to that, we need to fabricate, we need to connect all these connections on this breadboard. So first of all, we have to have the 9-volt battery. Okay, we have that 9-volt battery. So we wanted to connect this 9-volt battery connection to the positive rail of the breadboard and negative to the negative, or otherwise I can go for this also. I can use anyone. See, my dear children, my dear friends, I have connected the battery positive in the entire positive rail and negative on negative rail. Now what I need to do, from here I need to go for one switch. See, I have a switch here. So in the positive line, anywhere I can use one switch and I can insert that other terminal of anywhere. Now from there, and you know that this entire column has, so in this entire column, the positive of the battery is there. Now what we can do, from here we wanted to go for 100 ohm resistor. So where is the 100 ohm resistor? What are the colors for 100 ohm resistor? Brown, black, brown. Yeah, this is the 100 ohm resistor. But connectivity on this particular leads of the resistor, I haven't seen that clear. That's why I'm just scrapping. Okay, so now the copper connections have come. So now I'm going to connect this 100 ohm resistor here in the breadboard. See, in the same column. So this switch connection has come here. From here I have, now from here I have to take down to my water tank. So I can use, one jumper for going to my water. See, this one I will be taking to the water tank, okay? So that's okay. So this one will go. Now I need to fabricate another circuit for my transistor kind of thing, okay? Now what I am going to do, I have a transistor here. This is BC547 NPN transistor. I have cleaned the terminals. Okay. Now you all need to know which is the collector, which is the base, and which is the emitter. That is also another important. So here, so every transistor with every different number, they will have a different kind of. So I know this is the collector, the first one. Center one is the base. The third one is the emitter. So now, if I connect these three, suppose say in particular one column, it doesn't make any sense. Why? Can someone say?
Because we have to connect with other components in it.
So all these three, suppose say if I connect in the same column, then it is no point. So I am trying to show you, I have connected all the three, collector, base, and so this is no point because collector, emitter, base got short circuited in the breadboard column. So there is no meaning. That's why what we need to do, we have to connect in other direction. Okay. So in the other direction, because I am showing in the schematic drawing like this, what I am trying to do is, I am trying to take out the base little to the back side so that it will be easy for you guys. See now what I did, base backside, see I have inserted, you can see the base is in the center. In the center base, I am trying to take backside, okay? So now I am inserting in my breadboard wherever I want. Okay?
Yes.
But now even in this case we have a problem. The problem is the base has gone to some other column, that's fine. But now collector and emitter still in the same column. That's not good for us. That's why what I need to do, I have to shift that emitter or collector to some other column. That is also very important. You understood what I mean to say? Now again I am pushing them inside. You see, now clearly I try to understand, my dear thinkers. The emitter is on this number. I don't know. I can't see this number. What is this number? This column number.
11.
11?
12.
12. And now what is the column number of this collector? This collector?
13.
13. Now what is the column number? In which column I have inserted the base?
15.
15. Okay. So I have separated them. Okay, good. Now how I am going to do is I need to shift a little down this one. Why? Because I need some LED and all to be put into the collector. That's why. So another circuit I want to fabricate, as 390 ohms I had to give. So I am taking 390 ohms to the base signal. I am just cleaning the leads. Okay. Now this 390 ohm I am going to connect in the same column of the base. Okay. And see, somewhere else. Now I need a sense wire, no? So from the water tank, this wire, a wire from the resistor to this one. So I am using this one, right? So this one is this part, and this one is this one. Is it clear to my dear friends?
Yes,
Okay.
sir.
So up to here we have done. Now this one has to be done. This one has to be done. So what is that we will do for that? So the positive line is there, and we need 1K resistor here. Okay, so we will use this 1K resistor to give the required current for that LED. We can use 470 also, but that will allow little more current to the LED. To save the energy, battery energy, I am using 1K. Is it clear to all of you?
Yes, sir.
Now this has to go from positive to any other pin. I have no problem. Any other pin. So I am connecting the 1K. So I have inserted this one. Now you have to tell me after the resistance, the 9 volt after the resistance, where it has to go. Who is going to tell me? The 9 volt.
Has to go to LED.
It went to resistor. Now after the resistance, it has to go whom? LED, anode or cathode? So anode is here. The lengthy one is the anode. So that has to go. That has to go. So in the same column, I have to use this, right? Okay, I have done it. So the anode was inserted in the same column of the resistance. But cathode has come on the other side, right? So there is another column. So what I need to do, the cathode of that LED must be connected to the collector of the transistor. So now I am going to use another jumper wire, okay, to connect that. So collector, let me in which number is the collector? Yeah, this one, right? Okay. So in this, the entire column is the collector. So now that one I am connecting to the column of cathode, LED cathode. So this connection I just established the cathode of LED to the collector of the LED. This one is done that way. Now what else is left now? I think mostly we have done almost all except then the buzzer. Okay, buzzer also can be put into somewhere, wherever you want. Where do you want me to put the buzzer? So you tell me. I have again two connections for the buzzer, one positive and negative. Yes or no?
Sir.
So you tell me where to be put the buzzer positive and negatives, so that when the water, yeah, come on, tell me now where to be put.
We have to connect.
Anywhere I can. Okay, first let us test this circuit. Then where to be put into. So suppose if I am putting this buzzer here, is it okay?
Yes, sir.
Not at all. Why? Why it is not at all okay?
Because it's not connected.
No, we can connect with the jumpers. That's not a problem for me at all. But still there is a problem. Who is going to tell me that?
It's not connected with positive and negative.
Or not only that. You want to see that again?
Yes,
You see, my dear children, the positive and negative I am inserting. What is the problem I am doing?
the same.
It's in the same column. That should not be the case like that. So I must use another columns. Okay, positive is this side and negative is that side. So I can use the positive and negative connecting. So I can use the another jumper wires. Negative, I am taking negative. In which line it is going? Fourth one. Fourth one is the negative. So here. So it has to be okay. Now give me one more jumper. See. Now in the first, the positive is in the first column. It has to go to whom? The battery line.
Battery line.
Positive line. Okay. The negative has to go where?
Negative.
No. We are not going to play with buzzer with connecting battery positive negative. Only it must be on only when the transistor is on. So this has to go. I have not shown you earlier. This has to go to the same point. So whenever the switch is on, whenever the positive goes to the buzzer and comes out of that, and when this particular transistor is on, then this will get connected like this to the negative, and then this will be on. Like the way the LED is on like this, right? LED is getting on like this, like this, like this. Buzzer will get on because we don't need any resistance for the buzzer. That's why directly we have connected the buzzer to the positive, and output negative of that is not directly connected to the negative of the line, negative rail. Why? Because we want control. Only when the transistor is on, then only the buzzer must be on. So we have made the connections ready, and this has to be put onto that collector line. Collector line I can see here, yes, of course, here, here. Anywhere in the collector line we can connect here. Yes? Okay, that's the collector line. Now we can test it. So how do we test it? We'll connect the battery. Give me the battery. And we are connecting the battery. Yes, battery is connected, but nothing is happening there. No, switch is not on. So switch is also on. Now, okay, now let me send the signal to my body. The signal, battery positive. The switch is on. It is the positive has come from the 100 ohm resistor to this jumper to my body. And if my body connects back the same signal to this particular base of this 390 ohms on the base, then what happens? Let's see. So my body is not conducting. My body is not conducting. Okay. So I think so. So we need to wet my little fingers, then it might conduct. Give me the water bottle. I'll just try because my fingers are so dry. Otherwise little light might have come, but it has not come. Now let me see. Even now it's not coming. Okay, maybe my wetness is not sufficient. Now let me check and see. Even now they are not connecting, right? There is some problem. We need to figure out what is the problem. So LED is working or not, or LED is reversed or not, or the switch is not connected or not.
Switch is on.
Oh, I found it. You see, my dear children, what is the mistake I did, After the switch, we have not connected from the switch to this point. From the switch, we have connected this line, but from here to this line, we have not connected.
Yeah.
Oh, one more jumper wire. So this is how you need to figure out. I hope you are enjoying today's tinkering. So happy Technology Day. Harini, are you enjoying? So we are trying to connect. You might have given good jumper wire. Okay, now you see, in the same positive line, after the switch, I am inserting this one after the switch. Okay, inserted. Now it has to go to the collector line. Where is the collector line?
In
From where this fellow is going, even this one also, buzzer line, because buzzer are positive anywhere. See, buzzer positive also is getting to the same line. No, I can insert this one here also, because I have very clear access here. I can connect. From here, so that will get, wait a minute, positive line, not onto the negative line, positive line, because okay. Now you see this portion also got connected. Now let me check. See, is it on? Let me check directly, touch it and see. No. Is it this? This is on? No. So why this one, the battery after the positive? Now we need to check with the voltage multimeter. Give me multimeter. With the multimeter we need to check it. So this is how we need to figure out what is going wrong, where it is. Okay, now you see how I am going to test it. See, I have the battery connection here, negative connection here. Give me one clip wire.
So,
See, now I am trying to do this one. See, I am trying to connect my multimeter clip wire negative to the negative track. Oh, for the entire circuit, you guys have not connected negative. Then how it will work here? See, the battery negative is there, but this negative is not connected to the transistor. You people said, oh my God, there is something wrong here. You see, what you did, from the positive you have taken it, from there positive you have taken, this is okay. And the negative one, the transistor emitter, where is the transistor emitter? In which line is that?
12.
Which line is that transistor emitter? This one,
12.
this one. Yeah, okay, this one. Transistor emitter is this one. This one is collector. Yeah, it's collector. Emitter is this one. So there must be another jumper for transistor emitter to the negative. That one we have forgotten. Give me another jumper wire. So this one we have forgotten. What is that forgotten? The transistor emitter is not grounded. So where is the emitter line?
In 12.
This one.
So,
But already it is there. No, oh, it is connect. Oh, it is going for that. And that is, oh yeah, we need to connect this one. Transistor emitter. This is the emitter? Okay, we will connect emitter. Emitter to our breadboard negative. Why they are coming? They shouldn't come like that without.
switch is on.
Even then, because we have not connected these fellows, no. Without this, how the transistor is on? Okay, now this is what? Collector, right? Oh, we should not connect to that one. We should connect it to emitter. Oh, what we did is we are putting this one to collector. The negative we are putting to collector. We are bypassing the transistor. Okay, so I have used now to emitter. So this one, now I am going to connect to my negative, right? Hey. Okay.
Yes, sir.
Now the entire schematic is properly wired. Now I can see. Now let me touch with water. Let me see through my body. If at a little light comes on to that, then okay. Okay. Then we can go for real time. Little light? No way? No way? That means this negative one, where it is going? The emitter is there. There only it must get connect. That's a collector, base, in the baseline, what is that we are using? The baseline is where, the baseline, yeah, it is there. Oh, it is not connecting. Oh, this resistance is not connecting. That we will see. What happening, what is not happening, we will see. Okay. Now, this emitter, is it an emitter? Yeah, it is an emitter. We will connect to this one. Yeah. Okay. Now, why it is not coming on? Right? Okay. Now we will go with the multimeter. Give me clip wire. It is there. Now what I am trying to do with this clip wire, you see,
Have to connect it to negative.
negative, then I can trace the circuit. Where it is coming, what is not coming. This is troubleshooting. This is also very important. So now give me another clip wire.
Sir,
Yeah. See, my dear friends. Without clip wire also I can directly see. Now you see, I want to check my battery voltage. And before switch and after switch. It is okay, it is there. Yeah, after switch also it is there. And after that, it has to go to my 100 ohm resistor. So is it coming to 100 ohm resistance?
yeah.
Yeah, it is coming. After the resistance? Yeah, it is coming. And to this sensor. Oh, this sensor is not working. My dear children,
Something is wrong with
you-
the
sensor wire or the resistance, I don't know. See whether it is not ground properly. It is not pushed it here properly. Okay. Now where is that sensor wire? This one. This is how you need to figure out, my dear children. So getting a trouble is more interesting. You see, now also it's not coming. Let me check after this wire. Oh, it's not coming. That means the resistance. Let me check the resistance. Oh yeah, just this wire is not working. Give me another wire. The jumper wire. You understood?
Sir.
Because that is going to jumper, but after the jumper it is not coming. Now it is coming. Yeah? Yes or no?
Yes, sir.
Now let me see.
It's working.
So having a problem
With the jumper.
is not a problem. Having no problem is the biggest problem.
Yeah.
Because we miss opportunity to solve the problem. Now you are all very lucky fellows to get the problem. So that you know, because of this jumper
This
wire,
wire is not working.
so it is always to check before you use the jumper wires, whether they are working or not. How do we check the jumper wires? By putting this multimeter in
Multimeter.
buzzer mode and keep the two probes onto this, and this buzzer comes on, that means the connectivity is okay. Or otherwise physically they are okay, but they are not working. Electrically, functionally they are not okay. Because of this fellow, we are in trouble. Now we can really test putting these probes onto water. So give me any cup, teacup or glass. Okay, this is our water tank now. Okay, you can go and wash it. Come on, hurry up.
Bottle caps in place.
Okay, yeah. You have the bottle cap? Even this one, small, this one. This bigger one. Yeah, give me the bigger one. This is our water tank, colorful water tank. But water will come out.
Sir, I'll cut lock.
Lock up, but no leakage? Okay. Okay, no leakage? No leakage? Ask that boy. Anyway, ask the boy to bring water filled. Get me water. Meanwhile, we'll test with this water also. No, let him bring. We'll pour that water. We'll check with this water also. If it works with this water also, you will know something. Okay, it's a filtered water. If at all it conducts, it is conducting, but buzzer is not coming. It is not that conducting, so that the current sufficient enough to drive the buzzer is not happening. The transistor is getting on, but not that full on. Slowly it is coming, slowly. So the conduction is not sufficient enough. That means it is fully filtered. So pure water never conducts. Pure water is an insulator. Now, once that water comes, you change this, throw this water. Now you see, you just brought regular, normal, ordinary water. Regular usage water. You see? So this is how,
We have to figure out solutions for problems.
yes, you see, when our tank is full, you are getting buzzer and then you can switch off the motor so that water going into the tank will be off, so you can save the water, right? Is it clear?
Yes, sir.
So happy National Technology Day for my children. Happy National Technology Day.
Thank you, sir.
So I am going to switch off now.